Hi, I'm Aaron from DataStax, and today I'm going to take you through migrating an enterprise e-commerce website to the Table API, part number 2, the product subsystem. So we're going to have a look at some things like, some of the product accessor methods, and we're even going to have a look at how to do a vector search and get that to work using the Table API, which, by the way, is a whole lot easier than, how you have to do it with straight up CQL. All right, let's go. So as I mentioned last time, this is a continuing series that we're doing that's based on the e-commerce workshop that we used to run a few years ago. And the idea is that we have this great application that runs on Spring Boot and Spring Data Cassandra that uses the old CQL ways of accessing the table data in Cassandra and in AstraDB. And what we're going to do is convert that code to use the Table API without needing to touch the underlying data storage. Just a quick reminder here, the Data API allows you to work with Cassandra and Astra tables from a document paradigm. The idea, though, with the Data API is that it stores data in things called collections, real similar to what you see in a document database. You can access those collections by making RESTful requests, and we have clients available for, several languages, including Python, JavaScript, TypeScript, Node, and Java, of course. I should mention that you can also use curl for a lot of those RESTful requests that go straight to the Data API. Now, the Table API is actually a part of the Data API. But what it does is it allows you to work from a document paradigm on existing Cassandra tables. So you interact with and store your data in the regular, same old CQL tables that you've been used to forever. You use the exact same clients as you would for the Data API. And essentially, what you get is RESTful calls converted into CQL. And that's how it goes ahead and pulls all this data back. So here's our GitHub repository from the old workshop. I have forked it into this repository called Workshop E-commerce Prototype, which is an area where I kind of, experiment with some things in terms of, trying out new features and new aspects of the Data API and other libraries that we have at DataStax and other ways that we can work with things like AstraDB. But what I'm going to do is switch to this Table API branch. This is the one that Cedric Lundven and I have been working on to help put forth a path of converting a big enterprise project from the original, CQL data access methods and repositories that you would normally see with Spring Data Cassandra, and we're going to convert that into using the Table API. So this is basically it. If you wanted to, you could go out here and follow these steps, and it would help you to stand up this site on your own. But what I'm going to do is have a look at the site inside of my IDE. And I'm going to start by scrolling down here. Notice I am using Java 24, which is the most recent JDK available. Okay, right here. This is the most recent library available for the Data API. Now you notice it has this dash preview 1 on the end here. So the features that you're about to see with the Table API are indeed in very much an alpha-ish, beta-ish kind of a mode. So just be forewarned if you're going to delve into this at this early point. That being said, I have done a lot of this so far and I haven't noticed too many problems. But again, I just wanted to put out that warning that it is indeed, more of a preview type of a feature than anything else at this point. But general availability should be coming shortly. Anyway, so you want to make sure you have that dependency out here in your POM XML. Since I'm using Maven, I will have that in my POM XML. If we have a look at the product REST controller, this is where a lot of this really happens. We have these lines for our repositories that we used to inject at constructor time in Spring Boot. Well, now we have this data API services object that that we're going to inject. This is actually going to work as our data access layer or kind of a replacement for our repository. But you'll notice we still have the one for vector in here. So if I go through, you can see in the controller, we have our vector repository and we have our data API services. If I go down to the first get mapping here, that you can see this is for, getting a specific product by product ID. And if I come down here, you can see that that's the name of the method, that find product by ID, very simple. Works off of an HTTP request, sends in and processes a product ID as a string. And really what it does here, instead of calling the product repo find by ID, we're actually going to use the data API services object that we have. We're going to do a dot find product by ID. And then we have a mapper here as well. So we can go ahead and map that into something useful that we can return as a RESTful response. And that's really about it. So as you can see, this is pretty simple. Now, before we get too much further, let's have a look at the data API services. So if I scroll down here, you can see that we have defined, like our product table, our product vectors table, something else for product vectorize, which is a little more of an advanced feature and a way to abstract a lot of the things around performing vector search and other AI-based conversational queries with AstroDB. We have product groups out there. I believe last time I showed how we went ahead and built out the featured product repository for this. Cedric and I kind of went back and had a look at how I did that and kind of wanted a central place to put all of those methods. So the featured product repository that we had before kind of got rolled into this as well. We also have an embedding model here. Specifically for this, we're bringing in that all mini LML6, V2 embedding model from Hugging Face. When we work with vectors and perform similarity searches specifically, and I'll show this in a little bit, around the product recommendation service, that's the model that we're using for our embeddings. So that's good to know. Here we're actually creating the data API services database, and that gets used when we want to go ahead and perform a call out to AstroDB. You can see that we've gone ahead and put in a couple of getters out here, or finders, I guess, if you want to call it that. This one in particular, find product by ID, really just does exactly what it says. You take the product ID. This is what our RESTful method actually calls underneath. So it gets a hold of the product repository, which we've defined up here. And it does a find one, using equals on the product ID column and with the product ID value. And then, maps that as a product table entity using the as product mapper and actually sends that back as a product POJO. Now, if we go ahead and look behind that, there's one more thing here that Cedric actually built. It's called the Data API Configuration class. And inside this class, you can see that this is where we're pulling in our token and our API endpoint and even our key space name at this point. You'll see that we have some public beans set up here, specifically one for the Data API client so that we can make our calls to the Data API and thus the Table API. This is where we expose the database object. And here's where we start talking about the tables themselves. For our table, for the product table, we want to have a bean defined as table.product. And, essentially we're going to check, hey, does this exist And if it does, well, then we're going to return a handle to that. That way we can go ahead and run operations against that table. If it doesn't exist, we're going to call this db create table method. And that's where our product table entity comes into play. This is actually defined, and I kind of showed how to do this last time for the featured product group table. But, we're doing a partition by on product ID. We have all these other columns here like brand and images. Images is coming across as a set. We have a map of linked documents, so we can set type as columns.map. Then we can also define the type for our map values and the type for our map key. So you can switch those around if you need to. And this is really just the rest of our payload columns coming back, including specifications, which is also a map of string. And then on the bottom here, Cedric went ahead and created an as product mapper. So that goes ahead and maps everything out as far as the product table entity is concerned. Let's go ahead and make this work. So I can do a run as Java application. And yep, that's my main. All right, we are indeed running. Let's go over here and say 127, 0.0.1, 8080. Bam, there we go. So this is our e-commerce website that, this is the platform that we built up for that workshop. If I have a look, maybe one of these products here, there we go. You can see it comes up just fine. In this case, it actually is doing a product query that is calling that same table in Astra using the table API. So I can go ahead and I say large, I can add that to my cart. And oh, hey, this goes ahead and trips the product recommendation logic that says, hey, if you like this DataStax Astra one team long sleeve shirt, you may also like this DataStax gray track jacket. Pretty cool, huh? Anyway, let's go ahead and have a look at Astra for a second here. Click on my vector database, and we can go to our Data Explorer. Now you see I'm in my e-commerce key space, but I don't have any collections available. That's because every structure that's under my e-commerce key space, as you know, if you attended those workshops a few years ago, they're all CQL tables. And since our Data Explorer in Astra only works with collections, which are a special kind of CQL table, they don't actually show up here. So we need to go into our CQL console. All right, so let's do a use e-commerce and desk tables. Yep, you can see we have all those tables as a part of our e-commerce platform here. So let's go ahead and do a select star from product. And as you can see, yep, we have 35 product rows out here. So if I go back here, I can have a look at the cart because I've added it out here. You can see it's out here. If I look in here, here we go. DataStax Astra one team long sleeve tee medium. All the different sizes are out here actually. So yeah, given out at our internal summit a few years ago. So yep, that's definitely out there in the database. And as you can see, this is a CQL table for sure. All right, let's go ahead and stop this. All right, let's have a look at what it would take to convert our vector search on product recommendations over to the table API. So if I go to our product REST controller, let's go down to, yep, get promotion product. Okay, so here's the idea. What we're doing is we have a product ID. So whatever product we've just added to the cart, we're doing a find of that product by ID. And then we're taking that product's vector and doing a vector search on that. Yep, find products by vector. And that's going to pull back the most similar products. We won't need this product vector repository anymore. So let's get rid of that. All right. Means we can get rid of that. And then we don't have to inject it into our constructor anymore. Okay. So we can scroll down to here. So let's go ahead and comment that out. And then let's say optional product table entity, original product, data API services. Now let's have a look at data API services once here. Here we go. So if I scroll up here, yeah, here we go. Find product vector by ID and find products by vector. So those are already defined here in our data API services layer. So this is good. This will make it a whole lot easier than price. Truth be told, I have done this one a couple of times. But if I have the our product vector repository and I do a find, now normally this is where you would specify the column that you want to find on, but since we're doing a vector search, we're actually going to send null in that parameter. We'll go ahead and specify a new table find options object, and we'll execute a sort of vector on the product vector column with the vector value that gets passed in. We're going to say include similarity score as one of the columns, and we're just going to do a limit 8 on that, and then finally finish that with a toList to return that as an array list. So this is really what we're ultimately going to end up using. And if we take a look at this table, let's go ahead and do desk table product vector. Really? Oh, product vectors, of course. So as you can see, we just have the one storage attached index out there on product vectors. We have our product ID, that's our only primary key. And we have some other data about the product as well, because we don't want to have to make a secondary call for that. And here is our product vector. Notice it is a vector float 384, which matches up with our mini L6 model that we were pulling in from Hugging Face that I talked about earlier. And let's go ahead and do a select star from product vectors, and we'll say limit, let's go limit 2. Okay, so as you can see, we actually do have our product data in here, and that product description has been embedded as the product vector, as you can see there. So that's how this is all going to work. All right. Anyway, so what we need to do first is take the product that we just added into the cart and use its ID to pull back its entry from the product vector table. Then we can use its product vector column and do a similarity search for like the next available like product. So, all right. So let's go back here. Now that we kind of know what we want to do. So first thing we need to do is we need to find our vector data for that product by ID. So let's do, oh, here we go. You know, I should really go look at what that's called. Here we go. Find product vector by ID. You know, I'm just going to copy that. Remove all ambiguity. There we go. And we're going to pass product ID there. Okay. And that is trying to return. I am using the wrong entity type here, so let's update that quick. There we go. Product vectors table entity. Okay. So we have that all in there. Outstanding. Next, as long as we get something back, so as long as original product is not empty, I mean, I suppose we could use optional is present as well, but that's okay. It'll work the same way. Okay, so now let's get rid of that. And to go ahead and do our vector similarity search, we're going to do data API services, vectors, yeah, is that it? Vector search products, original product, get vector. Yeah, that looks right. Now let's update our entity type here. Oh, that didn't like that either. How about find products by vector? Yeah, I'm grabbing the wrong, yeah, there we go. There we go, that's much better. All right. And let's update our entity type here. Product vectors table entity. And then we have to update our mapper as well. Yeah, we can say product vectors table entity. And we need to update the method names here. So yep, get group. And I think this shortens to get name. All right, that looks good. Okay, and same thing. This goes back to just get group, right? Yeah, get group. There we go. Okay, and I think we're okay. So what this extra for loop here is doing is that it's taking the top 8 products it gets as the closest match to whatever product we just vector searched with. Now the thing is that what happens when you have clothing that you're trying to sell, you have all these different product types that are pretty much the same name, the same description, and the only thing different is the size. You know, small, medium, large, XL, 2XL, etc. So of course, if you're going to do a similarity search on a certain product number or a certain product description from medium, probably the closest one it's going to find is going to be the large. Now, that's not very useful to us. So what we're going to do is iterate through all the results that come back. We're going to check each product's product group. Now, the closest matches will have the same product group. So that's why we're checking down here. The first match we find that's the closest and has a different product group, that's the product that we're going to suggest. So that's a little bit about how this works on the logic side. All right, let's go ahead and give this a shot. Okay, that's running. Oh, and our web page resolves again. Okay, all right. Back to the beginning. Let's check the Apache Cassandra 3.0 contributor t-shirt. All right, I'm an extra large, so I'll tick that. And if this works, I should get a product suggested to me that's similar to this Apache Cassandra 3.0 contributor t-shirt. So if I say add to cart, oh, and look at that. I get this go away or I'll replace you with a Spring Boot annotation t-shirt. That's pretty cool. I should actually have that shirt made up. All right, so hey, this worked. All right, everyone. Thanks again for joining me on another episode of migrating an enterprise e-commerce website from using Java Spring Boot and Spring Data Cassandra over to the Table API. I hope that you're starting to see as we go through a couple of these, the value proposition that's involved here and all of the great features that this unlocks. So yeah, we'll continue on this journey and stay tuned for the next one. And we'll talk to you all later. Want more information on modernizing your self-managed Cassandra deployments? Head on out to datastax.com/modernize-apache-cassandra-workloads, and you'll find all the information you need on keeping your self-managed Cassandra cluster updated and in top running form. Thank you, and have a great day.